All right, this is problem number 3 from March 31st homework. It's the one, the depth of the Doe River, picnic point. Both the problems in today's lessons, this one and the next one, are very similar. I try to do that so you can see some similarities. The more of these that you'll do, the more you'll see it's sort of the same sorts of problems over and over and over. There's like, I don't know, 10 or 12 topics. On a typical AP test, they just ask you 6 of those, and it's usually the same 3 every year. I don't know what's going to happen this year. We'll find out a little bit more as we go, because I know there's not going to be as many problems. So, anyway, first question. This was the data, the distance from the shore, I guess, and how deep it was. It's 24 feet wide. I just drew a little quick graph of it, because we're going to have to use a trapezoidal rule. So the first one says use a trapezoidal sum with 4 subintervals to approximate the area of the cross-sectional river. So the area is just integral under a curve, right? So left-hand endpoint rule. I'm going to go through this pretty quickly because I think you probably know this. Left-hand endpoint rule. This one's 8, 6, 8, 2, 8, 6, 8, 2. Left hands are 0, 7, 8, 2, 0, 7, 8, 2. Right hands, 7, 8, 2, 0. Got 110 on the left, 120 on the right. Trapezoidal rule is the sum of those. 115 square feet. Part B, volumetric flow is the product of the cross-sectional area and the velocity of the water. So there's that 115 from here. And they asked me to estimate the average values. Remember, the average value is the integral divided by the length of the integral, right? So the average value of the function divided by its length times that 115 from this problem. Give me 1087.17. Just want to say something real quick. Trapezoidal rules now come up 2 or 3 times in these. That's the most common one. Every once in a while you get a Simpson's rule, less likely, so you might want to review that one. I'm going to send you some stuff for that later, as well as the midpoint rule. Midpoint rule, we just use midpoint, so we'd have to have more subdivisions. Part C is pretty straightforward. It says we got a function that models the depth of the water at a point that's x units from the river's edge. Find the area of the cross-sectional river. So it's just the integral from 0 to 24. Again, that function, which is 122.231. We're going to need that in the last problem. The last problem is really the same as B, except we're using the 122.231 instead of the 115 we used up here. And we're trying to find the average. Again, the question was the average value from in the 20-minute period from 40 to 60. So 40 to 60 divided by the length of that interval. That's the number from here. Times that, got 2181.91. The question was, is it going to overflow if it's more than 2100? So yes, it's more than 2100. Hopefully pretty straightforward. And this is kind of where these two problems were pretty much the same problem in there. So I'll move on to the next one in just a second.